Good morning, student. Let's begin today's topic. Factors affecting the state of equilibrium. Equilibrium constant. Which factors are affected? Write down the point. Very important point. Factors affecting equilibrium. Equilibrium state, and you can say Le-Chatelier principle. Le-Chatelier principle. The name of the scientist. Principle. What is the Le-Chatelier principle? There is a change in concentration, temperature and pressure. When in chemical reaction, there is a change in chemical reaction of concentration, temperature and pressure. The nature of the equilibrium shift to reduce this change according to Le-Chatelier principle. So what is the definition of this principle? Let's see. Change in any of the factors that determine the equilibrium condition of a system will shift the equilibrium in such a manner to reduce the effect of the change. When we change the temperature, when we change the pressure, when we change the concentration, equilibrium shift towards to reduce the effect. It may be backward direction, it may be forward direction. So equilibrium want to retain its position. When we change the condition, it shift towards there is reduced effect. So to clear this topic, what is the Le-Chatelier principle? So according to this principle, change in any of the factors that determine the equilibrium conditions of a system will shift the equilibrium in such a manner to reduce the effect of the change. So first point, effect of concentration. Effect of concentration. We already discussed in brief this point, effect of concentration of the reactant and product. We already explained the reaction quotient, equilibrium constant, how is affected the backward direction and forward direction. The concentration, so what is the point? The concentration of the product and reactant, if changed, the composition of the equilibrium mixture changes so as to minimize the effect of the concentration change. When we change the concentration like reactant, like product, then equilibrium shift towards direction where it reduce the effect, which may be forward direction, which may be backward direction. Okay. So according to this principle, like example, H2 plus I2 in gaseous state, 2HI, we already explained this equation. So what is the reaction quotient? Hi power 2 divided by molar concentration of the H2 and reactant. What is the numerator and denominator here? Hi and H2 and I2 is denominator. So it explains the adjustment. When we change the concentration of the reactant and product, they want to remain the constant equilibrium position. They oppose the effect of this change. So what happened in this condition? Let's see. H2 plus I2 when react, it form 2HI. So reaction quotient become Kc at the equilibrium position. Now, when product is removed, in short, you have to learn this point. When product is removed, okay, when we remove the project, it can again convert into reactant. And when reactant is added, in both condition, when we increase the reactant hydrogen or iodine, so it affected the QC. When we increase the reactant, then QC decrease and it forward to direction of the forward direction. When we remove the product, then direction of the equation is backward. Okay, I already explained this point. So don't confuse between Kc and QC. When Kc is in larger amount, then reaction is forward direction, and Kc is greater than QC. Now, second point, when reactant is removed, you remove the reactant, what happens in this condition? Let's see. You can write down this point. This is very important. In any chemical reaction, when the concentration of the reactant is increased, forward direction, products are present in maximum yield, high yield. If product is removed from its position, when we remove the HI, then H2 plus I2 completely consume and form the 2HI. There is no HI, so it can't decompose again. So when product is removed, this also explain the forward direction. Now let's see the second step. So QC is greater than Kc. Now second step, if QC is greater than Kc, about this condition, when reactants decrease the concentration, we can see or remove the reactant opposite, okay, reactant. When we remove the reactant, there is lesser amount of the reactant. How it is possible the product yield is maximum? Now you can see when reactant concentration is decreased, when reactant are removed from the reaction mixture, so what happened? Then direction is backward direction. And second point, when we add the product, if we increase the concentration of the product, reaction again backward direction. Now if we add the product and increase the concentration of the product, when we add the product, it increase the concentration of the product. What happened in this direction? Backward direction. So it's clear. So why this is applicable? This is applied by the Le principle. When we add the product, the concentration increase here and equilibrium shift towards left side to reduce the concentration. If we increase the reactant, then equilibrium shift to forward direction to reduce its effect. Le principle explain the change any condition and which reduce its effect to shifting about the shifting of equilibrium. Equilibrium shift from left side, equilibrium may be shift from right side. It depends on concentration of the reactant and concentration of the product. Now it's clear. There is again example of the effect of concentration. This is practical experiment. Let's see. And this point is very important. Effect of concentration in the following reaction. Let's see. Next example. Iron chloride in aqueous solution. We can take iron nitride, any iron compound, react with potassium thiocyanate. This is also aqueous equation, aqueous, and it form. We already explained this reaction. In salt, FeSCl2 plus aqueous solution. Clear? The color of this pale yellow, light yellow color. Okay, and the color of this complex is now reddish brown color. Reddish brown color, and its color is colorless. Now this is the equilibrium condition. Let's see what is the equilibrium constant, concentration constant for this equation. Fe product 2 plus aqueous and divided by iron Fe3 plus aqueous and SCN minus aqueous. This is equilibrium constant, and we explain by reaction quotient also here. Let's see. When we increase the reactant from both of them, we can increase the reactant of ferric chloride. When we increase the reactant of potassium thiocyanate. So in the reaction mixture, the reaction is proceed like this. When we add potassium thiocyanate, then reddish brown color is become more intense. First, FeCl3, iron chloride of pale color. When we add thiocyanate, potassium thiocyanate, continuously add, it convert into reddish brown color. Clear? Now, because reactant, the concentration of reactant we increase here, which explain the forward direction and reddish brown color. Now, when we add ferric chloride, now again we increase the concentration of the reactant. When we increase the concentration of ferric chloride, now Fe3 plus ions are free to react potassium thiocyanate, and again complex is formed. The dark reddish brown color is again formed. Clear? You can see when we increase the concentration of both reactant, what happened? Then QC convert into QC, and QC is become less, KC is become high, KC is greater than QC, then forward direction. Now it's clear. Now second step, you can see the second point. If we add potassium ferricyanide, if we add potassium thiocyanate, then forward direction. If we add the complex of the potassium thiocyanatoferrate, if we add potassium sulfocyanatoferrate, if we add, then reaction become backward. What happened? Because we increase the concentration of the product. If we add this complex, then reaction proceed backward direction. How to check? The color of the solution become pale yellow. Intensity of the color is changed, and if intensity of the color is increased, it means forward direction. reaction is backward direction. Now clear? So we increase the product, then reaction is backward direction. When we increase the reactant, reaction proceed in forward direction. Now again let's see, if we add in this condition oxalic acid. So what happened from oxalic acid? What happened? When we add in this reaction mixture after the equilibrium state oxalic acid. What is the formula of oxalic acid? COOH and COOH. This is the formula of oxalic acid. H2C2O4. So when we add the oxalic acid also react with iron. So what happened? Reactant is removed from the reaction mixture. Reactant is removed, then reaction is again backward direction. Because free iron is not present here. This free iron react with oxalic, which complex is formed, then react with FeC2O4 whole thrice. FeC2O4 whole thrice 3 minus. This complex is formed. Now you can see there is no free iron. If there is no free iron, how potassium thiocyanate react with iron? So when we add the oxalic acid in this reaction mixture, this also reaction take place in backward direction. Again, next point, if we add HgCl2, mercuric chloride. If we add in the reaction mixture mercuric chloride and Hg2 plus ion react with thiocyanate, there is no HCl minus free iron. So how they react with iron? Fe3 plus iron. So when we add HgCl2, so Hg2 plus ion react with HCl minus ion, thiocyanate. Oxalic acid, there is oxalic ion. Oxalic acid react with iron. So there is also backward direction. When we add the silver chloride, then HCl minus thiocyanate react with and it form the stable complex HgSCl. It will also form the stable complex HgSCl whole 4 and 2 minus. So what is the explanation now? HCl bonded with Hg. This is complex and it can never break. So there is no free thiocyanate ion. So now it's clear when the reaction backward and when the reaction forward. When product removed, then the reaction forward. When reactant increase, the concentration of reactant increase, then forward direction. When concentration of reactant decrease, when concentration of the product increase, then the reaction backward direction. It's clear? Now there are also examples in our body for the effect of the concentration. You can explain by the Lee-Chatelier principle. The next example of this, first, carriage of oxygen by hemoglobin in the blood. Next example, carriage of hemoglobin in the blood. Now there is also equilibrium state. When hemoglobin react with oxygen, hemoglobin react with oxygen, it form oxyhemoglobin. Oxyhemoglobin, and hemoglobin is now there is also present equilibrium state. What happened? The hemoglobin in red corpuscles of our blood carries oxygen to the tissues. These involve the equilibrium. The blood that is in the equilibrium with the oxygen of the air in the lungs finds a situation in this condition where the partial pressure of oxygen is low. Where the partial pressure of oxygen is low. So what happens in this condition? When oxygen is low, it means the body required more oxygen, then oxyhemoglobin convert into oxygen, then reaction is backward. When oxygen low, it means there is HbO2 is higher amount, product is higher amount, then reaction is backward direction. Where HbO2 is now, so it explains the nature by the Le-Chatelier principle. Then pressure, according to Le-Chatelier principle, the equilibrium shift towards the left so that some of the oxyhemoglobin change to hemoglobin, giving up the oxygen. When the blood returns to the lungs, the partial pressure of the oxygen is higher. Partial pressure of the oxygen is higher, it means reactant increase. When reactant increase, reaction proceed forward direction. Clear? When oxygen is lower amount, then reaction is backward direction because reactant is less amount. Sorry. So, and when oxygen is higher amount, then it forward direction. So, carriers of the hemoglobin in the blood is an example of the Le-Chatelier principle. Now it's clear. Next example, removal of carbon dioxide from the tissues by the blood. Removal of carbon dioxide. Removal of carbon dioxide from the tissues by blood. It also example which is explained by Le-Chatelier principle. And there is also equilibrium present. How it is equilibrium? CO2 gas when react with H2O, it form the carbonic acid H2CO3. Carbonic acid is very weak acid H2CO3 and it is in aqueous solution. It also convert into H plus and it also convert into H plus and HCO3 minus. HCO3 minus aqueous. It also aqueous. Let's see this equation. So H2O and CO2, this is liquid. When H2O react with the CO2, it forms carbonic acid. Carbonic acid back into H plus and HCO3 minus. So the removal of CO2, it also explains the amount of the reactant. If partial pressure of CO2 is increased, it means reactant increase, it convert into carbonic acid and it convert into this. Now, if partial pressure of CO2 is decreased, then carbonic acid, their reaction is backward and CO2 and H2 is formed. So it also explains the carbon dioxide dissolved in the blood in the tissues since the partial pressure of CO2 is high. Next point, sweet substance cause tooth decay. This is also example of our daily life. Sweet substance causes the tooth decay. Why sweet substance causes the tooth decay? This was also explained by the Le-Chatelier principle. So next example, sweet substance causes the tooth decay. tooth decay. How it is possible? What is the enamel? Tooth enamel consists of insoluble substance called hydroxyapatite. Tooth enamel. What is the composition of tooth enamel? Ca5, calcium, phosphate, PO4, home thrice, and OH. This is the tooth enamel. Clear? Hydroxyapatite. The dissolution of this substance from the teeth is called demineralization. If this is dissolved, this process is called the demineralization. Demineralization. Okay, if enamel is dissolved. So, the dissolution of this substance from the teeth is called the demineralization, and its formation is called the remineralization, and its formation is called the remineralization. So, what is demineralization? What is the tooth enamel? Hydroxyapatite is tooth enamel. If it dissolves, it is called the demineralization. If it is formed, it is called the remineralization. So let's see what happened on the tooth. There is also equilibrium present. How it is possible? Let's see. The tooth enamel break into which ions are present here? How many ions are present here? Ca5, PO4, home thrice, OH. When break into ions, it form 5 Ca2 plus ion. And how many phosphate ion? Phosphate ion. What is the charge on the phosphate ion? 3 minus, and hydroxide ion OH minus, all are in aqueous condition. Ions are present always in aqueous solution. So it break into this. If it break, that tooth enamel. If it compose, there is no tooth decay. So how it is possible? Let's see. When sugar substance are taken, sugar is absorbed on teeth and gets fermented to give H plus ion. What happened when we eat sugar items? So sugar substance are taken, sugar is absorbed on teeth and gets fermented to give the H plus ion. So what happened? H plus ion disturb the equilibrium and react with OH minus ion. What happened in this condition? Product is removed simultaneously. When we eat the sugar substance, then sugar is fermented and become acidic, reduce the H plus ion, and these H plus ion, this equilibrium present in our mouth, which stop the tooth decay. If this equilibrium disturbed, then tooth decay is present. So what happened? When we eat the sugar substance, they fermented and give the H plus ion, and this H plus ion react with OH minus ion and H2 is formed. It means basic medium is decreased. So to prevent the tooth decay, advise that basic paste is used. Basic paste which reduce the tooth decay. So H plus ion react with OH minus and product is removed. So reaction is in forward direction. So tooth decay is also example of the Le Chatelier principle. We can explain by this. So dissolving the enamel, hydroxyapatite causes the tooth decay. So it's clear what is the effect of the concentration and on the equilibrium state. There are different examples. We can explain by any example.